Hello everyone. In the last few videos, we have already discussed about convolutional layer, and after discussing about convolutional layer, we have gone into ReLU layer, and after completing ReLU layer, we also discussed about pooling layer. If you guys remembered in the last video, we told that in pooling, we'll be having something called as window size, and let's say window size is something like 2, and our input shape is, let's say, 8 cross 8. Then what we'll be doing based on what is our pooling strategy, like the strategies can be something like max or something like average. We'll be taking the window size into consideration. Like here 2 is the window size, right? So we'll consider 2 cross 2 portion, and in this 2 cross 2 portion we'll be taking out the maximum if max is our criteria, and we call that as max pooling. And that maximum one, we'll be placing it in the output. And after placing the maximum out of this, then what we'll be doing, in case of convolutional layer, we are just moving by one column, but now we'll be moving by two columns. That is based on the window size. So if the window size is 2, we'll be moving by two columns. Okay, so again we'll start from here, and now also we'll cover 2 cross 2 portion on the input feature map, and in this 2 cross 2 portion, whichever is the maximum, that we'll be placing it in the output. Like that, as the input size is 8 cross 8, the output that we'll be getting will be 4 cross 4, because we'll be having 8 columns and 8 rows, and we can cover with such 2 cross 2 windows, we can cover the whole 8 cross 8 portion, and the output that we'll be getting will be 4 cross 4. I hope this is clear. Basically, it will be like this. Another window will cover 6 cross 6 portion. So this is 8 cross 8 feature map. In this 8 cross 8, every time we cover 2 cross 2 portion. So this 2 cross 2 portion got covered, and that value, whichever is maximum in this, will be placed over here. And after that, we'll cover this 2 cross 2 part, and then that will be placed over here. And then again 2 cross 2 part, that will be placed over here, and again the last 2 cross 2 part, that will be placed over here. Like that, after this again we'll start from this point. Okay, as we'll move on by 2 rows, and also like that we'll cover the whole 8 cross 8 feature map, and we'll be getting the output of 4 cross 4. So I hope this is very clear. And the amount of movement of these rows and columns after applying one operation, that we call it as stride, and I explained this concept in the last video also. Let's see about stride in more details. So if you see what is stride, stride is the amount of rows or columns that we shift after completing the operation. Okay, by default in pooling, the stride will be equal to the window size. So what is window size over here? Window size is 2. That's why we are moving it by 2 columns or 2 rows after applying one operation. But in case of convolution, if you guys remember, we are just moving by one column, right? That's why the stride by default in case of convolution is 1. And we can also adjust this stride for, suppose, like in convolution, when, if you guys remember what we are having in convolution, we'll be having some input image or input feature map of size n cross n, and there will be something called as kernel or filter. The kernel or filter can be of size k cross k, but in case of pooling, will not be having any such kernel or filter. We'll just be having window size. Okay, using this kernel or filter, we'll be applying the convolution operation on the input image or input feature map that we are having, right? After applying the operation, then finally we'll be getting some output feature map. And if you guys remember, this particular k cross k kernel will be placing initially at this top left corner, and after placing it over here, once the convolution operation gets completed, then we'll move by one column in general, right? But it is not fixed. We can change that as well. If we are increasing the stride, what will happen? Once think of it and comment down in the comment section. So basically, if you increase the stride, the output shape will change. So let's say by just choosing stride equal to 1, the output shape will be n minus k plus 1 cross n minus k plus 1, and there will be third dimension as well that will be dependent on number of kernels or filters that we are having. Let's say there are m such kernels or filters, then here also we'll be getting third dimension to be m. But this will not change, right? This is dependent on stride, and if stride is more, then this will be very less. Okay, this portion, that is n minus k plus 1 and n minus k plus 1, will change in such a way that it will be very less value. So let's try to understand with some examples. Let's take some realistic numbers, then you'll understand it better. Let's say this is some 6 cross 6, and this is, let's say, 3 cross 3. And let's say the stride is 2. If it is 6 cross 6 and 3 cross 3, according to this n minus k plus 1 formula, what will be my output shape? My output shape will be 6 minus 3 plus 1, that is 4 cross m. Okay, let's leave m as it is. It can be variable, it can change according to the number of kernels and filters that we have. But here, if you observe, given an input shape of 6 cross 6, we are getting an output of 4 cross 4. If stride is 1, okay, this is when stride equal to 1. But if, let's say, stride is 2, then what will happen? First, we will cover this first 3 columns. And after covering the first 3 columns and applying the convolution operation on this 3 cross 3 portion, then what we'll be doing? We'll be moving by 2 columns. Previously, we used to just move by 1 column. Now we'll be moving by 2 columns. That means we'll start from here. Okay. So we'll start from this point and we'll cover till this point. For this operation, the output will be placed already because we have calculated using convolution and the output is placed over here. Now again, we'll start the same calculation of convolution operation on this portion, right? After calculating this, again, we'll be getting another output. And as we started over here, next operation should be after 2 columns. That means we need to start from here. But if you start from here, can you cover 3 columns? So if you carefully observe, we can only cover this column and also we can cover this column. But third column is not available. But the kernel size is 3 cross 3. Here there are only 2 columns available. As the third column is not available, we will not be able to perform the convolution operation. So this column will be left out. So we'll not be doing any operation on this. And then again, we'll move down by 2 rows. That is, we'll start over here. Okay. So as we came to the end, we start over here. That means, like, basically initially we covered this portion, right? That is 1, 2 and 3. Now we'll start from this second row and cover till this particular row. On this portion, we'll be applying the convolution operation. And after applying the convolution operation, we'll be getting another output. And similarly, after that, again, we'll be moving by 2 columns and again start from here and we'll apply the convolution operation and we'll be getting the output. So this column will not get covered and also this last row will not get covered. That is because next time you need to start over here, but from here, if you see, 3 rows are not available. That is the reason you will not be able to apply the convolution operation, and the output shape that you will be getting will be simply 2 cross 2 cross m. Okay. So 2 cross 2 cross m. But if you see over here, without stride, like that is with stride equal to 1, this is the output shape, whereas with stride equal to 2, this is the output shape, right? So whenever you wanted to reduce the input shape or input feature map shape drastically, then you can increase the stride. Okay. So if you wanted to keep more or less the same, then you can simply use stride equal to 1. But if you wanted to reduce it a lot, then you can go for higher strides like 2, 3 and all. Okay. So once you increase the stride, you are able to see some problem right over here. So this column and this row are not getting considered, right? So if they are not getting considered, then there might be a problem. In this row and column, there might be some important information left from the image. That can happen, right? We can't really say that in this portion there is nothing left. in some specific images in these last row and last column, some important information might be present. So that's why it is really important to preserve this row and column as well. Then there comes the concept of padding. In order to cover these missing rows and columns, we can use the concept of padding, and with the help of this particular padding, we'll be able to cover these rows and columns as well, and also we'll be able to get the output in lesser size. The next video we'll see what this padding is and how it can be useful in order to cover these missing rows and missing columns. Okay, I hope you guys are able to understand concept that I'm trying to teach in this particular video. And if you have any doubts, please comment down in the comment section. Thank you everyone. Bye bye.